All right, hello everybody, this is Ms. Piekarski. I'm doing another recording. In this video we're going to get into some of the things that I love so much about pre-calculus, and that's the unit circle and using sine and cosine and tangent and the other three trig functions. So in your notes you should have this circle here. A couple things I want to point out about our graph here. With this, our x values are always going to be the cosine of whatever angle we're looking at. And our y values is always going to be the sine of theta, or whatever angle we're looking at. Right now, I just want you to see this picture and say, oh, it's a circle. It makes a circle, okay, because that's what we've got. All right, in order to make this circle, I want to find my sine and cosine values of pretty much any type of angle. Doesn't matter if it's a positive angle or a negative angle, or it could be an angle of, let's say, 360 degrees, or maybe an angle of, what's 360 plus 90, 450. So if I wanted an angle of 450 degrees, I can find a x and y value for that, and by plugging in the angle to cosine of the angle, push enter, and it'll give me my x value. If I plug in sine and the angle and get an answer, it'll give me my y value. And no matter what angle, I will always get something or a point that follows along this line. Okay, so let's look at our table. So let's say I have negative 90 degrees. I can plug it into my calculator. I can go cosine of negative 90 degrees. As long as my calculator is in degree mode, then it'll give me a 0. Now, same thing, I could do sine of negative 90 degrees, and I would get a negative 1. But what if it was in radian mode? Okay, I can put my calculator in radian mode. If I do that, then I'm not going to enter negative 90 in for my theta or my angle. I will enter negative pi over 2 for my angle. Now this table, you don't need, it's not in your notes, you don't need to copy it down or anything. I'm just showing you that I can either plug in the degree and have my calculator in degree mode, and I'll get these two answers. Or if my calculator is in radian mode, I will plug in negative pi over 2, and I will get the same answers as long as I'm in the correct mode. Okay. I know most of my classes I showed you guys how to change the calculators from degree to radian mode. We will do that again on Monday when you come in, but I wanted to show you how this works ahead of time. Okay. You don't need to really do anything or calculate anything out at this time. Just know that you can change the mode of your calculator, and if you have your x values as the answer for your cosine theta and your y values are sine theta, then you will get points that will create a circle. Okay, so there's two tables. Notice there's lots of different values. Here I go from negative 90 degrees all the way up to positive 90 degrees. And then here I go from 120 all the way down to 300 degrees. We're going to have a lot of chances to experiment, to play with the table values, and we'll have lots of fun with it. So just be aware, if your calculator's in degree mode, you have to use degrees. If your calculator is in radian mode, you have to use radians. All right, moving on. So that's what all this stuff is about, degrees and radians. We can change the mode, and you get a circle. Let's see if there's anything else here. I'm hoping that you all recognize that this shape is a circle. It's easy to plot the points for cosine and sine. Just remember, cosine is always going to give you your x value, and sine is always going to give you your y value. All right. So now that we are plotting our trig functions on a coordinate plane, a couple things I need to make you aware of. First of all, some definitions and some different terms. Your initial side is always where the angle starts. And when you plug it into a x and y graph, you're always going to start on the positive x side. Always, 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 this is where you start. Okay? Your initial side is just where you begin. It's always starting at positive x-axis, and this angle is referred to as 0 degrees. Okay? Now, if let's say your angle is 360 degrees, that means you went all the way around your circle, and you're going to stop at the same place that you started at. Okay, that's fine. It's happened before. You will have problems where you're starting and stopping at the same time, or at the same place, excuse me. Your terminal side is just where you stop. Okay, if your angle is 135 degrees, then this is where you stop. Okay, couple things, counterclockwise and clockwise. When you are working with your grid, your angles always start at the positive x-axis, and if it's a positive angle, you're going counterclockwise, okay? If it's a negative angle, then you're going clockwise, okay? And that's where you get this information from. Negative angles start at the positive x-axis and go down this way. Positive angles go up this way, okay? Now, remember at the beginning of this, and I said if you have a degree that starts at 0 and goes all the way around 360 degrees, your starting point and your stopping point is going to be the same. Okay, those create what's called a coterminal angle, and we will see those a lot. So don't just brush off that term, you'll see it a lot. Anywhere that starts and stops at the same place. So 0 and 360 degrees start and stop at the same place. If you had the angle 135 degrees, this would be your terminal side. If you had negative 225 degrees, this would stop right here, and they share a terminal side. So they're going to end at the same point. Okay, so 0 degrees, you're at this point. 360 degrees, you're also at that point. So you're sharing the same end point. Okay. Right now, you want to know the difference between a rotation angle and a reference angle. Rotation angles can be very large. Sometimes they are huge, and they are often described as a reference angle. Because they're so big, we want to know the reference angle, particularly when you're doing extra calculations. Later on in this unit, we'll do some crazy calculations. You do not want to have to do a calculation with like 508 degrees, okay? So you want to find your reference angle, which is defined as the acute. What does acute mean? Acute means that it's less than 90 degrees, okay? So it's going to be acute. It'll be less than 90 degrees. It is always positive, and the angles that is going to be between, hold on, it's between the terminal side of a rotation angle and the x-axis, okay? So does it matter where you're stopping or which quadrant you're stopping in? You're always going to be going from the terminal side or the end line up or down to the x-axis, okay? So this would be my reference angle. Here my reference angle. This one here is my reference angle. On this example, I know this is not in your notes. This is your reference angle. And there are some times where your reference angle and the rotation angle is exactly the same. Okay, right here, this would be your reference angle. And then again, right here, this is your reference angle. All right, so all you have to do in your notes is tell me what the reference angle is. I've done A, B, and C for you. I just erased them. If this this angle is 320 degrees, then 360 minus 20 gives you 40 degrees. Okay, so this would just be 40 degrees here. With this one, you have negative 180 degrees. Well, if you have a straight line right here, that says negative 150, excuse me. If you have a straight line, then this is 180 degrees. 180 minus 150 gives you 30 degrees right there. Okay? And then this one, same kind of thing, but you have a positive angle here, but you still have a straight line. How can you tell the difference between your 180 degrees here and this little segment here, you're going to take this number and subtract by 180. Okay, and you get 27. I will tell you, forewarning, these three problems are going to be your warm-up problems tomorrow. So if you can figure it out and just bring in the answers, and it'll take you like 2 seconds when you come into class on Monday. All right, so last thing I want to tell you about in this video is an easy way to find your reference angle when you're given a rotation angle. And you're just basically going to add or subtract by increments of 180 degrees. So if you have a negative, here, let me move back up. So when we had this negative 150, add or subtract by 180 just so that you can get a positive acute angle. Right here, 180 minus 150 gives you 30. This one here, I've got 320. If I subtract by 180, let's see, what do I get? I get, that would be 40, right? 100, hold on. So 320 minus 180. Let's see, cross that off. I know it's crazy when I'm trying to do mental math in the middle of this. So yeah, 140 degrees. Well, guess what? I still don't have an acute angle there. So what I'm going to do this time, I'll do 180 and I'll subtract by 140, okay, to see what the difference is. And look at that. I get 40 degrees, okay? So the shortcut, or the easy way to remember how to find your reference angle, is to take measurements of your rotation angle and subtract or add multiples of 180 until you get a positive angle that is between 0 and 90 degrees. Okay, sometimes you will add 360, sometimes you'll subtract 360, it doesn't matter what the angle is. Okay, so for these problems, I believe they're all in your notes as well. Let me see, I have about 3 minutes before the bell rings, so I'm hoping to get through this. All right, I'm looking in your notes, and it does not look like I included those. I'll go ahead and give these to you. I may have planned to have these as a warm-up problem, so guess what? If you watch the video and you jot down these notes when you come in on Monday for your warm-up quiz, you already have the answers. All right, so let's see, we have a positive angle that terminates in quadrant 3. Let's talk about our quadrant super fast. So this is quadrant 1. Most of you already know this, but you never knew why. This was quadrant 2. That's a 2, by the way. This is a quadrant 3, and this is quadrant 4. Okay, that looks really weird. Let me redo it. Quadrant 2. Okay, most of you know this from your earlier classes, but you never knew why did it go counterclockwise, and why is this one 1? I mean, normally we start from left and read to right, correct? And then we work our way down. But remember, with your angles, you start at the positive x-axis and you're going counterclockwise. The first quadrant we get to is the first quadrant. Then we're getting into the second quadrant, then the third, and then the fourth quadrant. Okay, so the reason why these are ordered the way they are is because when we have a rotation angle, this is where we start, and that's the order of quadrants we go into. All right, so let's look at our problems again. We have, let's see, it terminates in the third quadrant, so 1, 2, 3, right here. The reference angle is 71 degrees. So remember, it's always going to go to your x-axis. So this is 71 degrees, and we want to find what the rotation angle is, okay? So with this situation, you are adding 180 to 71 degrees, and you get to 51. Easy, right? Most of you should have been able to do that without a calculator, okay? So now what happens if you terminate in the third quadrant again, but your reference angle is 17 degrees, Let's see, there we go. So now smaller angle. This little tiny angle, 17 degrees. What am I doing wrong? Oh, all right. Find the measure of rotation angles between negative 360 to positive 360 that have given the characteristics. Okay. We want a negative angle this time. So instead of having a positive angle, I want a negative one. So negative has to start here and go this way. So all I'm doing is I'm taking 17 degrees away from 180. And notice they have a negative 180. You can do 180. Sorry, that's the end of the bell. I'll wrap this up super fast. So you can do positive 180 minus 17 and then just make it a negative, or you could do negative 180 plus 17. Either way works. Quadrant 2, positive angle with 24 as a reference angle. So this is 24, and you need to find what this is. So 180 minus 24. Quadrant 4, let's see, with a reference angle of 24 degrees. So again, back this way, notice I'm always going towards the x-axis. This is 24 degrees. And I still want a positive angle, so I'm going to take 360 because I have if I kept on going, I would have a full circle at 360, and then minus 24 gives me 336 degrees. All right, so I know this was not very entertaining. Hopefully this helped you. We will probably go over this part for the warm-up. I'll probably have it part of the warm-up problem. So sorry about that. I gave you the information ahead of time. Please remind your friends to watch the video and take notes on it. And I will see you Monday.